I want to thank everybody for joining us tonight. We've had a lot of success with our Getting to Zero program this spring, and we appreciate everyone who attends, and we hope that you're learning something. Today we have a presentation by Hans Hartmann, and Hans is going to be talking about heat pumps and more, and presenting some case studies. But before we do that, I want to introduce you to C-Free. And C-Free is a working group for the Green Energy Committee. We get together every other week, and we plan things like this presentation series, and we're planning an electric vehicle show for July. And we discuss what is relevant and going on in the world of sustainability and reducing carbon footprints. We started this series last year, and we did a number of presentations, and they are all recorded, and they are available on our website, lincolngreenenergy.org. So if you find this one interesting, please visit our website and look for more. This year, our presentation again focuses, many of our presentations focus on retrofitting the home, but we've got a few others that are very interesting and take a different turn. Today is Hans Hartmann. Coming up in June, we're going to be talking about how to reduce your carbon footprint through your food choices. We're hoping to do a presentation on HERS, and we're hoping to do a presentation on the Pierce House as an example of a historical home and what you can do to retrofit. And please don't miss our electric vehicle show at the Pierce House on the 4th of July. And with that, I am going to turn this over to Stephen Duran to introduce Hans Hartmann.
Good evening, everybody, and welcome to tonight's C-Free event. We thought it would be great to take a look at some case studies that may reflect some of the challenges many of the local homeowners are dealing with. I had the chance to meet Hans about 5 or 6 years ago. I had polled a number of subcontractors to see who was really on top of all the latest technology. I was introduced to Hans. Hans comes from Estonia, had come to the US to study mechanical engineering at Northeastern University. He ended up working for a number of local contractors and then started his own business. Hans is incredibly learned and certified in many of the latest HVAC and heat pumps applications, ERVs. He worked with the Thrui family for certification, well known from This Old House. And he has done a number of large-scale installations, commercial and residential, in the town of Lincoln. So I'd like to introduce you all to Hans Hartmann from Hartmann HVAC.
Hans, while you're getting your screen up, let me just tell the audience today, please put your questions in chat. And Scott Rodman, Scott, wave your hand there. Scott's going to be collecting questions and organizing them to present them for Hans at the end of the presentation. So please use your chat.
So hi, guys. Thank you for having me. Thank you for a nice introduction, Steve. I've been doing this type of work now for the past 20 years, and past 5-6 years I've been on my own. All I can talk about today is basically the equipment and systems we've been installing on our own experience, and what challenges we are facing with them as well. So mainly there's a lot of different heat pump systems out there, and not all of them are designed to fit every applications, every house. Generally people understand that the heat pump, and they all think that it's actually just a mini split. The heat pump is just a mini split, is just one of them, different options what is out there. There mainly what we work on is the standard velocity heat pump systems, what are basically systems like you have, if you have a gas-fired system or oil-fired hot air systems in the house, then this is what we can use to actually install your standard velocity heat pump system in your house as well. There's also the different kind of options, what would be the high velocity heat pump system. That is actually a system what is requiring less of the ductwork installed and runs in a quieter operation and is actually more efficient. The third option what we mostly install is the air-to-water heat pump system. It's been in Europe for the past 10 years plus, and it's been functioning perfectly. Finally, now the US market is starting to pick up with the air-to-water heat pump systems, and having the better insulation in the houses, that is actually allowing the air-to-water system actually function in the American houses as well. I mean, first of all, I'd like to talk about the regular standard ducted heat pump systems. So if one house has existing gas furnace or oil-fired furnace on electric system, then it would be fairly easy to install this regular ducted heat pump system on that type of house. It does require some kind of some modification on the ductwork, mainly to make sure the ductwork is designed correctly with a proper CFMs, cubic feet per minute, in mind per room, and it has a proper insulation because the heat pump actually functions in the lower air temperature coming out of your vents. So if you have a ductwork what is currently not insulated properly, then you will just lose so much out of it that the air coming out of the vents is just cold. I mean, if I can show you some of the pictures, what the air-to-water, the ducted system would look like, if I can find it. How can I share that? Okay, so this is what normally the standard ducted system would look like in a house. It is bulky. It is taking a lot of space away in the basement or attic, and it's not always a perfect solution for the every house. It has a lot of components. It requires a proper design for it to actually function properly as well. So it is good option to have in the houses it's just built, so it can be designed right from the beginning correctly. Or if it's a retrofitted house, then it's a little bit difficult to use on that application. Let's see. Okay. So we have another option where we can actually show I don't know if you guys see the share or not.
Yep.
The share? Yeah.
Yeah, we do.
Okay. So this is one of the options what we just did recently. We just finished up. It is a full heat pump system where we did use the existing ductwork. It did need to get corrected to some case, but it shows you the physical size of equipment, what needs to be fit in a certain place, and the amount of insulation what needs to be installed on the ductwork itself to be actually functional properly. On this application, we do have the humidification system installed on this equipment as well to provide the proper humidity levels. And we also have the ERV system always installed in the equipment to provide the fresh oxygen levels in the building. This is just another angle from that installation. the current house on that installation actually had the gas-fired boiler existing, and it was just a 1 year old. So we ended up actually utilizing some of that installation as the emergency heater. And that is actually just a hydronic coil what gets connected to the unit. So this system is actually a two-stage heating system currently now. It has a stage one, what is actually the heat pump, and stage two is the emergency heater, what would be still a gas boiler at this point. We have different options where we ended up installing the heat pump system onto the restaurant in downtown Boston. They had an issue with the air quality in the restaurant and not being able to get the proper temperature in the dining room area. So we just ended up removing the unit from the kitchen and installing it on top of a bar, and they were able to actually get the temperature controlled properly. The standard ducted systems actually are also able to be installed as the hybrid systems, where in a colder climates where the heat pump is not always an option, then it can be run as the hybrid, where on this case, we have a gas-fired high-efficiency condensing furnace installed with the heat pump itself, what will switch over the heating on a -5 degrees outside, and then it switches over to gas-fired furnace as the secondary stage. It's one option out there, specifically if the house cannot be insulated to the proper level, because the heat pump, it does require proper insulations on the house itself. We have just another option of the heat pump installation, where we do have actually now been able to fit this old system underneath the a small boiler room, where we used every inch of the space basically just to be able to fit it all in. But we still have a humidifier, we have an ERV system, what provides a ventilation. We have a proper filtration system in the house and a steam humidifier. I think that's pretty much it for the standard ducted systems. It has its benefits, it has its disadvantages. The benefits are that if your current ductwork is already available and it's a fairly decent shape, then the ducted heat pump system can be installed fairly good, easily. The disadvantages are that it is bulky. It is going to take more space away from the living quarters, and it also running on the temperature what is not really uniform on the room, and it can also have a higher ductwork losses because of the system's existing ductwork is not fully sealed. Second option of installations what we have is actually high velocity heat pump systems. So they are using a small duct to move the air on basically 3 times the speed as the regular ducted system is doing. So if the regular ducted is moving generally 900 to 700 feet per minute, the high velocity system is moving air 25 to 3,500 feet per minute. So it has a multiple time difference on the airspeed. The advantages are that the high velocity system, we can use a smaller footprint and we can use the smaller ductwork installing into the house. The it also can provide you quieter and more comfortable heating system in the house, because the air is moving so fast in the room. It is causing actually aspiration, so it mixes the air in the room better than the standard ducted system does. If the air gets mixed better, it actually is quieter as well. So the high velocity system can be whisper quiet, and if it's designed correctly, we have used these type of systems in the different applications where, let's say, in a home theater, if you require the very quiet ambient noise levels in the building, and or if you're just sensitive to any kind of air movement noises. The high velocity is actually, if I find you where it is, see that. Easily. Can't see anything anymore on the pictures. Where can we? Sorry. So, okay. So let's try this. Let's do the sharing again. Yep. So we have now the components of the one high velocity heating system, where the duct itself is actually a third of the size what we have on a regular velocity air system. And all those little flexible ducting is actually a smaller duct what is routed through the different obstacles, and are designed with a specific fabric what is actually absorbing the air noises. So it's capable of transferring heating and cooling on a more comfortable level as well. This is one of the systems what can be, and this one we actually mounted in the attic. So it's a physical size what you guys now can see versus the high velocity versus the standard ducted system. And those little flexible ducts in here are coming down. These are the attenuators what actually deliver the air onto the different applications. This is one job when the physical size has been seen now versus with a homeowner who wanted to be in the picture, and what was involved in installing one system onto the house. On that job, we actually had two separate zones again. So first floor zone and the second floor zone. And all the ductwork is actually positioned that the homeowner can still insulate and finish up the basement, what they wanted to do. The high velocity has a lot smaller diffusers coming out of the air, but sometimes in the different applications where there is really no room to put a lot of ductwork or the vents, they can be grouped out as this application we've seen on a little more modern house design. And even having the 10 vents like that in one location is not affecting the air movement noises. Its system is still whisper quiet. But this is one of options what you can have on the ventilating.
So those come up through the wall.
So this application, yes, they either have the cavity behind the wall and then the vent's going to be done, or they can be fit inside the 2x4 wall. So if you have a framing actually coming straight down, the vents coming up and then they can be terminated like in this location. They have a right angle, yes. This is actually what the vent would in the ceiling would look like. So it has a very low and small profile, and it's just more inconspicuous actually. On this location, again, the vents are designed, and as you one can see, you don't need too many of them if the house insulation is up to date. Normally, if the house would have less insulation, you will see those vents a lot more, and you will have to find a place to locating them. Again, one of the options of showing what the high velocity vent in the ceiling would look like. Or we have a different option where the vents are different shape. So it gives you options and design options as well. Again, the systems can be designed and hidden in the locations where it really doesn't bother anyone. This is one of the larger systems we just did very recently, where the homeowner actually wanted to keep the fossil fuel in the place as an emergency, because it wasn't that old and it didn't want to be thrown out. But the equipment, the heat pump itself is over here, and it has 3 separate thermostats for each floor, and all the components what are involved in it. It shows that it even for this high velocity system and the small duct, it still is quite busy, as you can see. It has a lot of components what has to be fit in a certain location. So if the design is required, and then for the heat pump system like this, then one just has to be considering the space, what is needed to be able to fit the system as well. On that location, we brought actually ductwork onto the 3rd floor through next to the chimney. So instead of doing 3 separate heat pump systems and 3 separate condensers, we used 1 large condenser and split it into 3 different zones. And we brought, each floor has its own ductwork brought up onto the attic, where we're able to distribute the ductwork on the knee walls with a minimum, basically minimum repair works needed to be done. We still had to open some sections to be able to fit the systems, but it's not that intrusive as the regular ducted system would be. High velocity system is actually relying only 1 return air to go in through the system. Therefore, sometimes when the ventilation is in the attic, there's a need to run ventilation through the doors. So instead of opening a door, we just came out with a design to put the screens through the dividing doors. Therefore, the homeowners can actually keep the doors closed and still have airflow going through it. This is one of the options where the high velocity termination is actually coming up through the floor. This particular is the red oak and is unfinished yet, but it is flush mounted design where you can just basically walk over it. It's a part of the flooring. And as the location is set, it doesn't affect your daily commute. So if you walk over it, you don't get the blast of cold air getting in your face. Another option on the same location as we position them away from just the path of everyday walking. And this shows the components also of the 1 high velocity system on the Victorian we did in Newton last summer. It shows the air handler unit with the multiple add-ons. It blows the air through the return system onto the supply systems, and it also has the 2 separate zones for 1st floor and 2nd floor, so it can be zoned nicely. And the duct system can be fit onto the between the floor joists, so it's not that intrusive. But equipment what we use is also we install the all-house dehumidifier system running in conjunction with the AC unit. So therefore, it can actually dry out the air in the summer instead of running the air conditioning full blast and try to dry out the air. We're actually using the all-house dehumidifier to dry the air out, and then we distribute that cooler air around the house. This setup actually also required the whole house humidifier in the winter, because as they had just the requirements for the proper humidity levels in the building. Another option for the small believe it was a 2,000 square feet house where there was no way of bringing the return air onto through the floor, but we were able to install the return into the finished part of the basement and build a custom-made ductwork lined with acoustical insulation, and therefore still have a whisper quiet system in the house. But that shows the physical size, what is required again on the smaller house. The basement height is standard, 7 foot 3, 7 foot 8, and we'll still be able to use and fit everything on that location. Another option, again, sometimes equipment, I mean, we're fighting with a space in the basement because every basement is normally filled. And that location, we were able to install it underneath the stairs. So it just takes the custom ductwork design, but it can be done. Another option like that. Normally, when we do a ductwork design in houses like this, we try to utilize the center beam location, what is always in the houses with a basement, and install the ductwork right next to it. Therefore, if there's ever a need to finish the basement, all the people have to do is now just soffit that in and put the box around it, so you don't then lose any headspace really. The heat high velocity actually shows a simple picture of here showing what it looks like on the diagram, because that's what I told earlier, that it can be zoned on the different thermostats. On this case, it shows you how the one thermostat is controlling a damper, directing airflow onto the second floor zone, and the second damper is conducting airflow onto the first floor zone, because the ductwork actually can be ran in between the wall cavities and the ceiling cavities to reach to the location where it has to be. So it's a less impacting. I guess that's it for this one. I mean, for the high velocity, I mean, we've been using it 99% of the times we've been using high velocity systems, because they've proven to be more useful and versatile and usable with the older and retrofit houses. The system was designed in the 40s, and originally it was called actually jet heat, because the little air nozzles and the diffusers what are coming out from the floor or from the ceilings, they push the air out so fast that it actually works as a little jet engine. But if it's designed correctly, again, I'm emphasizing it has to be designed correctly, because if it doesn't get designed correctly and somebody installing who has no experience installing it, one cannot pretty much stay in house, because the air noises are going to be so uncomfortable. And if the locations of events are not chosen correctly, then one cannot stay there. So we've done over years, we actually had to redesign some of the systems being installed previously by somebody else. Third type of systems what we normally install is actually and fairly new for the American market. It's the air-to-water heat pump system. The air-to-water is, again, it's designed to operate on the very low design temperatures, and it's designed to operate pretty much constant for the constant temperature. So what I mean by that is that one doesn't really need to fluctuate the temperature on and off. So you would actually just set the one temperature at fall and you leave it until the springtime. So it just maintains constant flow through your radiators. So the air to water, what it is, it's actually capturing the air, the heat from outside air, and it transfers it to the water. So water or the glycol mix. So as the water has been transferred, as the air heat has been transferred into water, and then it's going to be circulated through your existing hydronic distribution system. So if you have, let's say you have the existing radiators in the building, and you're looking to upgrade to the heat pump systems, then that would be one option to do. The important thing is that the house has to have a proper insulation level, and that doesn't go just with the air-to-water system. It goes also with the air-to-air systems and high velocity and regular velocity systems. The air-to-water system is actually running even lower temperature waters through the system. But if the insulation levels are designed correctly, then it can heat up the place super efficiently. It's mainly designed to work on a radiant heating systems, but it also can be used on a panel heating systems or cast iron radiators. The baseboard systems, what are quite common in the States, is not a best option, and it may have to be corrected or retrofitted. But if the system what you have is existing, then that would be a perfect option, because the one unit what we mainly use is actually capable of heating the opaque boards or radiators. It's also able to provide the domestic hot water for the showers, and it also can provide a cooling. But cooling element would be now not the refrigerant based like air-to-air is. The cooling actually comes out as the through the water. So you circulate the water through your air handler coil, and that's how you can actually achieve the cooling. What we find where we can show the pictures of it. Let's see. We have velocity. Find them. Away from here. I gotta find the pictures.
It's buried under there.
It's buried somewhere. Where are all my pictures?
Is it under that?
No, I can't. I gotta delete this one so I can find these pictures. I mean, the air-to-water cooling system and heating system is ideal if you already have existing, but if one would design the house from the start, then one can actually design whatever they want to look for. Let's say if you add all the radiant in the building, then the air-to-water system would be one of the great ideas to use it.
Maybe somebody wants to ask a question while
we're trying to find the pictures.
Load this last folder.
One of the questions that's been asked is about ductless. If you can touch upon those ductless systems.
Yeah, so ductless system is actually a fourth option what we also been installing. We are not really big fans of ductless systems because ductless is only capable heating or cooling. It really doesn't provide a good air quality in the building. So what we are mainly emphasizing is to provide the proper air quality in the house. Ductless is an option if there's no other options available, pretty much. To me, the ductless is basically as a space heater. One can install them, it can provide, and if it's designed correctly, it can also be 100% capacity for the heat pump, I mean, for the your temperature needs in the house. But a ductless system, it can present its challenges. And mainly what we see issue with the ductless is that if people have allergies or any kind of respiratory issues, then if the ductless system doesn't get serviced annually, it can actually build up a layer of a black mold on it. And then all you do is actually just circulate through that, through the house. A ductless system is an option, but it just one has to be very careful of actually servicing them all the time. I mean, all the systems have to be serviced. At ductless, to me, it requires actually a little bit more work.
So you have to-
Stephen, can you, Ernst, can you comment on the question? One of the questions that was asked also is about insulation. And I think the common issue that's been raised all along has been the issue of insulating before you go and do any kind of a retrofit.
Oh, absolutely. And so insulation is the key for everything. Doesn't matter what kind of system it is. If it's ducted, ductless, or air to water, doesn't matter. We design the houses always with a manual J calculations. That means that we go to look at the job at first, and then we measure up the house and always look at the existing insulation levels. And we try to talk to the homeowners, what are they planning to do with the insulation, and if they're willing to upgrade that. Once we know what insulation levels are gonna be installed, then we can actually design the equipment size based on that insulation. If the insulation doesn't get upgraded, then it can result in a higher energy cost, and it just is not overall a pleasant feeling in the house, because then, like I'm saying, that the heat pump systems are running on a lower air temperature or water temperature, and the airflow coming out is feeling cooler. So if you have a regular house when you had the hot air furnace, what was ran by oil, and one would now install the ducted heat pump system there, that system is airflow is now constantly changing and it's feeling cooler for them. Therefore, it's sometimes not comfortable or pleasant at first, and it's taking time to get used to how the heat pump system actually works. Because the heat pump, like I said earlier, is designed to run constantly and one set temperature. So if one would set the temperature in the house, let's say to 70, it will pretty much stay whole heating season at 70. Because what is happening, it's actually modulating the airflow coming out of the vents based on the outside air temperature. So the refrigerant is actually basically communicating with outdoor temperatures to provide you the proper airflow and the air temperature coming out.
Ernst, another couple of questions here.
Yeah.
Operating temperatures for heat pumps, that's changed in recent years with new technologies and so forth. Can you comment upon the efficiency levels and what down to what level and so forth?
So efficiency levels actually on the heat pumps are, let's say the last one I was doing was the air to water heat pump, and -4 degrees Fahrenheit outside, the air to water can give you 149-degree water coming out, and its efficiency is 150% efficiently. So one thing is that it's 150% efficient. Another thing is that how do we keep that 150% efficiency in the house? So that comes again the question about insulations. So one would really need a good insulation levels in order to keep up with the efficiency, because the system can be 500% efficient, but if you can't keep that efficiency and heat in the house, then the cycle will have to be repeated constantly. Therefore, you will still burn a lot more energy than it's needed.
Can you,
Yeah.
sorry, was that,
Yeah.
I was going to go to another question. Do you, was that it? Is that the full answer?
Yes.
Okay. Belinda asked a question about maintenance requirements for heat pump systems. I presume, with what you raised about ductless, can you talk about ducted also?
So ducted systems requiring the annual maintenance again. And annual maintenance just, it means that if the condenser, what is outside unit, is located in the area where you have a lot of pollen, normally what we see, the pollen's being actually deposited on the condenser fin outsides, and it packs them up. So therefore, there's no airflow going through it. So once a year, what we always recommend is to go by there, and we wash the coils out with the specific solutions to make sure that you have a proper airflow going through it. Because if there's any airflow obstructions on the fins itself, then the heat transfer cannot happen. So therefore, you just are losing efficiency on the system. Another big issue is that the inside unit is called evaporator. That is also a coil. It's like a car radiator. It sits on it's in the hot and humid environment. And in that environment, a mold usually tries to take a hold on right away. So if the systems and air handlers doesn't get serviced again, the mold, the virus will actually spread around the ductwork. And that can be also spread around the house and can cause the respiratory issues. The biggest thing what a homeowner can always do is to replace the air filter. Depends on what design the filter you have. If you have a 5-inch thick filter, then it would have to be replaced every 6 months. If you have the 1-inch thick filter, like the one can buy from the Home Depot or any stores, these are basically designed to be replaced every 30 days. So depends on what your system is. That's you'll have to see what you have to do on that. But as a maintenance requirements, any kind of system still requires the once a year maintenance, like any kind of a fossil fuel system requiring.
And can you touch upon the ductless also for the maintenance on that?
So ductless is the same thing, that the equipment outside unit will have to be serviced once a year. It will get washed out. The inside heads, what I call the mini split heads, these systems have the small screen on top of them. And that small screen will actually, during operation, the more you operate, the more you have to service them. So those screens will have to be serviced basically every two months. So you just have to take the screen off and wash it up and put it back together. And then once a year, somebody should have to come and actually wash the coil out again to make sure that the black mold doesn't take a hold on it. And also what we found an issue is that the drains on the ductless systems, what is actually directing the condensate water out of the air, these get clogged up with the algae. So basically, again, the bacteria is growing in the ductwork and in the drains itself. So they do all need a maintenance. And maintenance it's like a car. If you don't change the oil in an engine, you ended up replacing the engine soon. So any moving part, you still need to do some kind of maintenance on it.
And so Stephen asked the question: if you have a hydronic system, a baseboard system with no AC or ductwork, what system would you recommend for a homeowner to explore in conversion to a heat pump?
First of all, we have to see on the project what kind of radiators one would have. And then I'm using actually the German product, what's been out in Europe for almost 10 years, and it's proven itself to be one of the most efficient and highest efficiency system. But it actually it comes as the kit where you can have your domestic hot water and your heating system all in one, and it actually just takes the footprint of the washer dryer in the basement, and that unit can also do cooling as well. The brand of it is actually Stiebel Eltron brand, what we've been using on the air to water. That system comes in the multiple 2 sizes, and it can be basically added together to accommodate the larger house design needs. So let's say if the one size is just enough for the smaller house, if one has a larger house, the outside units actually can be twinned together parallel to feed onto the one inside unit and just have enough energy to be distributed that way. But if the house has the baseboard heat, what is most common in the States, because it's actually the easiest to install and the cheapest to be installed, that type of distribution system actually requires some kind of upgrades for the radiators. So either we will have to change those baseboards out to the low temperature baseboards, what's also available, or they can be changed out to the panel radiators. So this one would also require some kind of additional work to be done. Yes, I don't know if I'm sharing actually a screen or not, so I can actually show what it is.
You try hitting share again.
So let's see if I'm sharing.
It's also on that Stiebel Eltron. That's not, they also make the heat pump water heaters, correct? But that's not
Correct,
tied.
yeah.
You're not,
they do also make the hybrid water heaters.
Yeah.
And they are a very good product. And they have proved, I mean, they've been 100 years already out there. So they've proven to be a good product.
And interestingly enough, their U.S. headquarters is in Massachusetts, and Mr. Stiebel lives in Massachusetts.
Correct. Yes. Yeah. So headquarters is Massachusetts. So I can show you the share the screen of the air to water heat pump systems. So generally, there is a 2 type of air to waters. One, what is a monoblock system, what is actually up in here. So that means that all the refrigerant is actually outside of a building, and there's no refrigerant inside. As the refrigerant is changing more towards the propane-based, therefore it actually becomes more flammable. So newer refrigerant blends are already, they are eventually going to have requirements of the, where we can't really, you can't vent them in the house, and you can't have any leaks. So the monoblock system, what is also a Stiebel Eltron, what I'm using, it therefore is a better option because it's a safer option to have in the house. The monoblock then means that all the refrigerant is outside, then you just circulate your hydronic water through your radiators and the heating system through the unit, and it gets then conditioned based on the heating or cooling. And then one gets distributed through the radiators or radiant, or it can actually be blown through the ducted system. So it gives you different options. Another air to water system is a split air to water system, where we have outside unit, what is as a regular condenser, and then you run the refrigerant lines again through the house, and then you have inside a house heat exchanger, what is then going to be installed as a regular, let's say, wall-hung gas boiler. And out of that one, again, you distribute your conditioned water either through your ducted system or through your radiators or radiant system. So a lot of installers who are more familiar with the installing a high efficiency gas boilers, this is fairly easy for them to install. Sorry.
Yep. A couple
Yep.
questions that one of the Andrew asked a question about insulation for the attic. And if you have a system located in your attic, do you recommend insulating the rafters instead of the attic floor?
Correct.
How dealing with the envelope and the best way to approach that?
So
dealing with ice
the
dams, also
system-
the concerns over that.
So if the system gets installed in the attic, and imagine that the attic is not insulated, the rafters are not insulated, you just have it on the floor. The system itself is producing heat or cool, and the temperature is running inside the ductwork in the attic, or in the summer, they are running at the 48 degree temperature. So it's very cool in the ductwork. The ambient air in the summer in the attic, what is not insulated, is going to be over 100 degrees. So normally in the physics, the heat wants to go towards the cold. So if the 100 degree air temperature outside in the 40 degree temperature in the ductwork, therefore the one ductwork will just not going to hold. You have the insulation, what is great for the ductwork size, but it's not enough to be pushing away that 100 degree temperature attack towards the 40 degree temperature. So therefore, if your system is sitting in the unconditioned attic, what is uninsulated, then normally you will lose about 30% to 35% of the system capacity. So that means if you have 100% of system size design, but it's sitting in a unconditioned space, you only use 70% of the equipment now. Therefore, it's undersized. You're still going to pay all the energy use, but you actually just use 70% of the equipment. So therefore, we always recommend to get a building envelope insulated and bring the ductwork in a conditioned space. Therefore, it's in the even basement, or if it's in the attic, then it will have to sit in the conditioned space. Normally, we try to put the systems in the basement because equipment what can produce a water in the face of in the summertime when it can actually produce a condensation water. We always try to avoid having equipment up on the roof or an attic, because that can produce potentially just a water leaks through the roof. And we also don't like to put them in the attics because they can produce the noise, what would be unpleasant for the occupants on the second floor bedrooms usually. But is that good answer for the question?
Andrew, did that give you what you needed? Okay, if you need any more on that, please put it in chat or speak up. That's one of the questions. Also, deck houses. Have you had much experience with deck houses?
So deck house is tricky, very tricky house. First of all, because it has not a great insulation levels, and we did last year or 2 years ago one deck house where we ended up using a ductless systems, mini split systems, and we were able to get a full 100% of coverage for the house with multiple heads and locating them so that don't basically just are not very intrusive. But the insulation is the big issue. It can run 100% heat if it's designed properly, but one would have to know that it's going to cost more to operate. because of the insulations what are on the deck houses. Because the normally the windows over there are single pane and not always replaced to the double pane or triple pane. And insulation levels on the roofing on the roof deck is normally about 2 or 4 degrees. I mean 4 inches per foam insulation. So it's doable, but it's just, yeah, it requires more of the different approach. On the deck house, if one would not need the cooling that much, then the air to water heat pump system would actually be perfect, because one can actually run the higher temperature through the baseboards. And on the deck house, you can also change those baseboards if there's hydronic water, heat. Those baseboards can also be changed to the panel radiators or the high temperature baseboards.
Murat, you asked the question about deck houses, and you'd asked if you could talk with Ans separately. I think that you can arrange that. One of the things we found from the discussions in the C3 group is that deck house is a very important topic that we're addressing to a greater extent, and actually doing a Colette and Chuck have done a lot of work with one local deck house owner with doing some work and looking at the house and it's where it's losing energy. The roof, the windows, and the air sealing are the 3 biggest issues. And the slab is sort of the 4th component of that. And
normally it's in the basement part, but the I mean, I can tell you what I did in my house, because I don't have a deck house, but I have the house what is on the slab as well. I ended up actually demoing the entire slab, because my house was built in a 53. There was no insulation on the slab at all. So actually I ended up keeping the walls open, and I took my concrete flooring out and I poured a new concrete floor with insulation and a radiant heat on it.
Out of curiosity, what did you use as insulation underneath? Rigid foam and then slab on top?
2-inch. There was a 2-inch with a vapor barrier and the radiant tubing knobs on it. So I'm using the Viego product, getting it insulated.
Do you want to comment on that vapor barrier also?
So the ones we were using is actually has a vapor barrier already installed on the insulation panels. So basically you just snap them on the gravel below the concrete as the Lego. Basically, as I put it together as a Lego. And then it also provides you now the path for the radiant tubing to be installed underneath.
I think concrete. For a couple of the folks, they may want a little bit more information. So you took out the concrete slab, you dug down, you put gravel under, you put gravel stone underneath, correct? Yes. Then you put this, and you say Lego. Can you describe what you mean by that?
So it actually comes as I believe 2x4 pieces of styrofoam insulation. What has one side covered with the hard plastic, what is the vapor barrier. And these 2x4 pieces now are gonna be basically laid on the gravel and snapped together to provide the whole uniform coverage underneath the flooring.
Okay. And we're hoping to do more in C3 with deck houses, and are encouraging, we hope that Mass Save will actually see the light and come up with some prescriptives for deck houses, or at least allow some money for a little more money than they have allocated, which tend to be very expensive.
The deck houses are beautiful design. They're beautiful houses, but yes, they're requiring a little more work to be done to be actually to be more energy efficient. And one thing is the windows. The windows are huge, and they normally are single pane, or the just have sometimes they have a storm windows on them. So the hydronic air to water system actually would function great on them. And on the deck houses, if you don't want the air movement really, one can actually utilize the if you do put in the radiant heat, one can actually utilize the radiant heat mass also as the cooling element. If the humidity levels are matched and the dew points are controlled, then on certain area times you can actually use the radiant heat and use it as the cooling. That requires then the humidity to be removed either via the whole house dehumidifier to make sure that it doesn't condense on the floor, or you have some kind of ERV system still installed to remove the moisture from the air.
And that's a requirement if you're going to do that, though, correct? Because otherwise you end up with a serious.
Correct. You have to be. I mean, the system what we're using, you can do the hydronic cooling, but it requires the specific room thermostat to measure the dew point and humidity in the air, and therefore it will actually control the water temperature in the flooring to be able to prevent that the dew point and condensation on the floors. But in the New England, I mean, in US weather, that type of cooling is you don't move that moisture out that much, so you still need some kind of the air movement to be able to remove the moisture.
And one of the things you've shown is that every house that you've shown has a different solution for it. So one of the things that becomes a question is when you're looking at these are all, there's no cookie cutter approach. It's except maybe for except more for deck houses of the fact that these are the following things, but every other house has sort of on its own.
That's why I'm saying that this is basically 4 different options what we've been using. Every application is when we go over to meet the customer, we talk them what options there are, and we try to tailor to the specific house needs and their specific customer requirements as well. What are they looking for? And then we'll sit down with the customer and walk through what kind of installations they have and what are they actually willing to install, because that will determine the equipment size, what's going to be installed, and if it can be only one equipment or multiple, and that will eventually determine the price of the equipment and the whole job installation. And if one would not do that, then it can be a nightmare.
And your view on a blower door test also? Do you consider that part of this process?
This would be after everything is done. We normally haven't required to do that, but the homeowners they can do that afterwards as well. We normally don't do the blower door test before and after, but that can be certainly done. Yes.
If anyone's wanting a blower door test, basically just looks at how well sealed the house is and how much air is coming in. At any one time.
The sealing of a house, I can say my own experience, what I did, because my house is pretty much as the test house. I super insulated it, and when we did design the range hood and the kitchen design, something was changed. So instead of taking the inductive and the recirculating cooktop, we ended up putting the cooktop what requires the exhaust vent. So of course at that time I wasn't really able to incorporate the fresh air intake onto the in the house. So I ended up with when the exhaust fan was coming on, I wasn't able to open my doors to get outside because the house was pulling into the negative pressure. And also what happened is that everything what was in the chimney was pulled in the house through the fireplace. So you can imagine what can happen. And also when my bathroom fan was coming on at this point, to this day, I don't have a doorknobs on the house yet because I'm still under construction. When I'm at the shower and the bathroom vent comes on, my door opens up by itself because it sucks it open. So I always have to put something in front of it so it doesn't get sucked open. But
if anybody has any desire to get in touch with you, how do they do that? Can you put it in the chat, or can you just tell me and I'll type up? Actually, you know what? I could probably find it, or Colette has it.
Yeah, we have a phone number and email we use. We can share over here. And normally we don't have much of an online presence because we are a smaller operation where we don't really advertise what we do
You're
at
too
this
busy.
point right now. But
And
the,
do you also support all of the, do you work with Mass Save for the for the rebate programs?
correct, yes. So we are Mass Save installer list currently, and we like I said, we do work with them. We are certified by different installers who we have actually worked with before, like a different manufacturers, LG, Bosch, Spacebek, Unico, and so on, Stiebel Eltron. So we try to install the equipment what we've have experienced before, and we know that how they operate and what they've done actually for us, and trying to provide you the most reliable system. One thing I do want to also mention now is what we found out on our own is that installing any kind of heat pump system nowadays in the States is actually requiring to have clean electricity, what I call it this way. What we've seen now, like about 10-15 years ago, we had the same issue with the gas systems. When the on-demand gas boilers came in the picture, then the gas pressure dropped in the distribution, and therefore it had no heat. What we find out now is with heat pump system is that when the demand goes very high on certain areas, it can cause the voltage to drop significantly and enough to actually damage the equipment. So what I was speaking to the different manufacturers, and what are they telling me is what happening in the system is that if the voltage drops so low, then the equipment just gets out of this threshold, then the system doesn't get lubricated. It actually seizes up the compressor outside and also damages the electronic components.
How much can you actually know? How much can you test for that beforehand to know whether they're prone to that?
So you cannot do that. We just had to change out one of the 1-year-old mini split compressors because of the system ran 2 years until the homeowner decided to install the electric car charger. What is a large 50 amp car charger? And electrician did not really know much about it, and they installed it, and within a week it blew up the adjacent compressor because the voltage dropped. So you need a perfect storm to this one to happen. Therefore, you need to have everyone running in your neighborhood, high demand on electric, and you happen to, let's say, run your car charger at the same time. And what happens is, yes, the voltage will go out of the threshold and it will actually damage the equipment. So what we on all our installations we're doing is actually installing the voltage regulators and surge protectors with the equipment to prevent that one from happening. We cannot provide the stable electricity to the grid unless you're living off grid and you have your own battery backups and you provide one steady voltage. Mm-hmm. But what we can do is actually we can interrupt the power going onto the condenser to actually try to save that from getting damaged. But on a certain neighborhoods, we've found that to be more happening.
Okay, we're at 10 minutes after the hour. We have a couple more things that I think have been raised in the past. What size electrical service do you need for, and what is the expansion potential for that, given what it does to your service needs when you're making a conversion?
So electrician would have to actually come. That's a part of what we also do. When we go look at a job, we also include electricians as well, who will have to do the load calculations on the on your existing house. Sometimes we can get away with the you need to have minimum 200 amp of service.
All right. Are there any other questions that anyone has tonight that that they would like to pose? Just at this point, I think just speak up if you just unmute and ask and ask a question.
Yeah.
Okay.
I can say that on my house, I just had to change my service out to 400 amps now.
Which is a very expensive change.
Yes, and if I would have known that, let's say 5 years ago, when I was starting to design that, I would have been able to include it a lot earlier and a lot cheaper.
And load
And it took
management.
a long time to get that 400 amp panel as well.
Yes, it does. Load management is becoming a bigger and bigger issue to reduce the size needed
Yes.
to have things basically just planned out in terms of usage and so forth. It's all a fascinating and evolving area. Colette, did you have any other questions or comments tonight?
You know, Ans, you were talking about the standard systems. We have a very small mid-century modern home. It was actually built before deck houses were introduced, so it's not quite the same style. We've been extremely happy with our standard, but it's a very small home, and the heating system is extremely efficient. We never felt a transition going from gas to the standard heat pump.
But you've also done many different good projects to modernize and do retrofits on your house that are impressive to see.
Well, we did, you know, we improved our windows for sure, and the roof was huge, having good insulation in the roof, but standard systems maybe get more compromised in larger homes, but for a small home, we found that it worked really well.
Well, Ance, we can't thank you enough for taking all the questions and for giving the presentation, and Nancy for helping to organize, and obviously Colette and for her great work. So I think if anyone has any questions for you, that I presume that what'll happen is when this goes out as a follow-up in the next few days, I presume we can include your email address or something to if people want to contact you.
Hans, I think you're on mute.
Hans has been muted.
I have a
Oh,
little
there he
helper
is.
here.
There he
who's
is.
Helping.
Okay.
I was actually saying that earlier for your installations, Colette. I'm always saying that if one can insulate the house enough, then that you can heat it up with the 100-watt light bulb, that would be the goal. But if you're trying to heat up a tent with the heat pump, that's never going to work. You may feel in front of it warm, but it's actually just going to be going through your roofs again. So more insulation you can add in the house, you never can go wrong with that, because that would be the first. I mean, that's the best investment one can actually do, no matter what kind of heating system they have, wood or oil, or it doesn't matter. But if you can keep it in the house, then you'll actually you get those rebates from the day you install it until you move out from there.
So that's an encouragement. If you haven't already had Mass Save come in and do an evaluation and looked
Yes.
at what the options are for that,
Yeah.
there are a bunch of other programs. Mass Save will give incentives. There's also the Mass
Yes.
Heat Loan Program. There's the AEC
Absolutely.
program, which we are going to do a event on as well. These are all great incentives to encourage people that provide a lot of funding for it as well. And impressive things that everyone should at least go through the process of having their house evaluated and get the impression of what you can do and the steps forward.
And even if I'm saying, if you don't want to do the heating system first, always try to go with a maximum insulation levels one can do. And if you don't change the heating system this year, change a year or two after, because if you improve the insulations, then you're already bringing your footprint down, because you're not burning as much on whatever you're burning.
I'm looking at the amount of insulation we put in the new house and the and how incredibly, we haven't moved in yet, but I mean, incredibly comfortable it is as a result of that. It's just, it's always a feeling of just, you know, coming into a house that's warm.
And the constant temperature. Like
Yeah.
my walls on my raised cape are now R31 on insulations. And my roof line insulation is actually R70.
Whoa.
So my 2,000 square feet house, I can heat up with just a 2 tons, 24,000 BTUs.
That's great. Well, this
And
is the
that
direction.
stays,
This is the
and that
direction
stays at
going forward.
76 constantly.
Yep.
Well, Hans, we want to thank you so much for joining us tonight. Really
You're welcome.
appreciate your time. And this has been very, very well done and excellent information. I want to invite anybody that's joining us tonight. If you are interested, join us at a C-Free meeting, and we are always glad to answer questions. So we welcome visitors. If there's nothing else, I want to thank everyone for attending this evening and join us again.
Thank you.
Thank you. Thank you, Scott, so much for handling the questions.
Thanks, Colette. Thanks, Ants.
Thank you, Scott. Thank you.
Good night.